Good morning. I'm here to talk a little bit about renewable energy and to help get you into a mindset where you actually feel like you're a crew member on Spaceship Earth. You know, we have to protect this. It's not a garbage scow. We want it to be a cruise liner, okay? And this is my contact information. Most people had it at the end. I forgot to put it at the beginning, but it's still there if you need to look it up later. I also have cards. So this is about renewables, but I really want to underscore what Dan has talked to you about, and that is we have to make sure we do efficiency first, okay? Once you do the efficiency step, it's our opinion, after having done this since 1975, I can't quite say 45 years, but it's close, we have reached the point where we've turned the corner. It's all cost effective. You should be able to invest, if you have an energy investment policy, and go to a 5-year payback, 6-year payback on efficiency first, and then cut the cost in half of what you need to have renewables do, which will also pay back in probably 5 to 6 years here in Illinois, or less. So imagine in 6 years not having a utility bill in your plant, okay? Just as background, the United States in 2017, the most recent year for which I had current data, we were using what is called quads, 97.868 quads. Now, looking at what's happened over time, you can see the green and the red lines here. The red line is energy usage, and the green line is our real GDP adjusted for inflation over time. So you can see from the 1950s to the early 1970s, those two lines were right on top of each other. And when I first started out in the energy consulting business, I was always told, well, you know, we can't have economic growth without using more energy. And I said, no, that only means we continue to waste the energy we've been wasting at the same rate that we've been wasting it. And that showed very clearly in 1973 with the first oil embargoes, right in here. We immediately decoupled energy use from economic growth. People woke up and they started working on it. And rather than keep telling everybody that, hey, we got tons to do, I want to emphasize how much we have done. At around 2000, energy growth stopped growing in the United States. So we've increased, since 1970 and the first embargoes, we've increased our total energy burn in the United States about 1/3. We've tripled our economic power, okay? And just so that you know that we've done a good job, there's still more we can do. This slide also answers the question, well, yeah, but what about population growth? Well, we've absorbed population growth over time. This is the energy use per person in various economies around the world. But just before, and we've been flat. Here's the US, we've been flat. But just to let you know, Europe has done a whole lot better. They're using less than half the energy we're using today, per capita, per dollar GDP generated. You can't normalize it further than that, I don't think. But this just shows we've got a gold mine to go after in efficiency. Because, you know, they're not doing a whole lot more with renewables than we are right now. And by the way, these data I haven't updated since 2007. But the US has been flat since the year 2000 in its total consumption. So this would be trending down. See, as it's starting to trend down here, it will still be trending down because we've still had population growth, but we've kept our energy usage the same. And we've continued to grow the economy. So, my premise has always been, we're going to be mostly renewable energy. It's just a matter of time. And I can tell you, the economics favor it as starting right now. and you need to get on board with that, or at least help your companies get there. So, what are the renewable energy sources we generally look at? Well, we have what we call direct solar, and we can drive thermal processes with that, or we can do photovoltaics and make electricity directly. We have indirect solar sources. In other words, if the sun weren't shining, they wouldn't be there. We have wind, we have biomass, we have hydroelectric, we've got wave energy, we've got ocean currents, we've got geo-exchange with, that's what a lot of people call ground source heat pumps. And we have ocean thermal. Now those are indirect solar. Now geothermal is actually making it from steam-based sources deep within the earth. We have lunar tidal forces. We got waste streams. Now ideally we're going to reduce those waste streams, so I don't want to count on them for future energy production, but I do want to use them for interim energy production. But let's get rid of the waste eventually. The other thing I'd like to point out is that combined heat and power, while a lot of people don't consider it a renewable energy source, it's an energy source where we can cascade and continue or reuse the energy that's in a process. So, it may be a little difficult to see, but well, we'll keep going. I just want to point out, this was a study done by the Energy Information Agency of the DOE, and it showed that in 2015, their projections for the year 2020, right here, and where the relative economics would be for a variety of different agendas for making electricity. So they compared everything to a baseline of conventional coal combustion processes making electricity. So they called that 100%, all right? And then we're comparing renewable energy sources, which are in this light green background. You can see that as you go down. And there's two kinds of power that we have to consider, okay? There is non-dispatchable technologies and dispatchable technologies. Now the non-dispatchable are the ones that are intermittent, that the utility can't depend on to be there all the time, like solar and wind. Geothermal, however, is a renewable energy source that is dispatchable. Therefore, you can see that its number over here is in blue, not red, which is non-dispatchable. What I want to point out is the way that it is discussed is, what is the levelized cost of electricity? And they talk about it in cost per megawatt hour. So this, when we're talking about $95 here as the levelized cost of coal, conventional coal, it's saying that each kilowatt hour you're buying is an average of 9.5 cents. So that's how you look at it. So it's telling us that in the year 2020, geothermal is going to be less than 5 cents a kilowatt hour. Now, I don't know where that's happening yet, but I like the idea, okay? That's something, when the petroleum industry shuts down, we've got all those drilling rigs that we can put to work making geothermal happen, okay? There's life for that industry coming up. So, looking at the variety of the different renewable resources, let's just go click through them quickly. We're looking at geothermal, and it's again, less than 5 cents, projected in the year 2020 on 2015 data. So that's geothermal. Moving down to wind, there's wind farms going up all over the place. You see a lot of them in Illinois. But the value is, they were off a whole lot in their 2015 forecast. It didn't take to 2020 for wind to reach 77% of the cost of coal at 77.3 cents. It's now already less than 5 cents a kilowatt hour, already. Power plants are going in all across the country. And we'll show you the range of that. I think that's $30 to $60 a megawatt hour. And then you go to hydroelectric. Well, I don't want to encourage more hydroelectric because that has other environmental unintended consequences that we don't want to deal with. And in fact, BPA up in Northwest is talking about how do we save the salmon by taking out a few dams. Okay, so I don't want to depend on hydroelectric in the future. Now, there's a lot of biomass opportunity out there that we haven't dealt with successfully. It's coming online, little bits at a time, but mostly in the waste cycles. There's algae that they want to make vehicle fuels from, and then there's all the waste from animals that is a huge opportunity down the road. And when you look at solar, we've got PV out there that they were projecting at 12.5 cents a kilowatt hour. Well, solar has come on now, and it is now $43 to $53 per megawatt hour, according to Deloitte and Touche. So they're already less than the projected geothermal in 2020. Solar thermal, when you're thinking about it at this scale, putting collectors on a roof, it's not cost effective then. It's not cost effective now. I don't expect it to be cost effective. I've been trying to put that on buildings since the early 70s. It has never penciled out. Okay? So it's a good thing to think about, but we've got other better fish to fry. So, as an example of this, the town of Georgetown in Texas, about 6 years ago, went out with PPAs, long-term power purchase agreements for solar and wind, 150 megawatt hours of solar and 144 megawatt hours of wind, that now drops power to the city at 4.5 cents a kilowatt hour. So they are power independent on electricity, and they will own all their assets when the PPAs run out in about 20 years. But currently, they're buying it for less than they were buying it from the municipal power utility grid in Texas. It was already cost effective. It's here today. And that creates jobs, and it does a lot of good things like hedge against future fossil fuel price and regulatory volatilities. And the other good things about, this just shows that you don't have to do everything right where you're located. All right? I just want you to keep that in the back of your mind. You don't have to put all the solar or all the wind on your property. You can work and condominiumize with others power purchase agreements for wind and solar elsewhere in the country. Again, it's a few more steps of what have to happen, but it is all still cost effective. They're getting the wind from up in the panhandle of Texas, and they're getting the solar out near El Paso, and it's all wheeled to them across the grid. Now they're on the same grid, so they can actually claim that we're effectively getting the electrons that we generated. The other values are, when you're not running a coal-fired power plant, you don't need water. And in a drought-stricken state like Texas, you save tons of water when you move to renewable fuel sources. Okay? And then we've got great advances going forward in storage mechanisms now. So we're looking to that bridge. There's a bridge coming up, and it's going to be happening. So we're going to use storage, and then it's a lot less cost effective. I mean, a lot more cost effective.
What kind of storage method do they use?
They're working with a company out of Europe right now that's going to use their town as a potential storage site for just electrochemical storage, batteries, effectively.
Giant battery.
Big and well distributed. You know, they're not all going to be in one place, I'm sure. So, here we go. We got wind and solar PV. Those are going to generate electricity for us. All right? We've got CHP. It's going to be electricity and heat. And then we've got the biomass type stuff that's out there, waste streams, and that's heat and natural gas. So everybody always talks about renewable energy, and we think about replacing electricity. We got to replace the gas too in order to become net zero, or effectively, something like that. So when you look at it, Deloitte and Touche said wind, and this is the reference down here. I don't make these things up. Look how long these things get. you know. But anyway, wind is $30 to $60 a megawatt hour. Solar is $43 to $53 a megawatt hour. CHP, you can't really give it that kind of number. Each one has to be individually studied because it's functionally how many hours does the plant run. If it's a 16-hour-a-day plant or a 24-hour-a-day plant and you're using a lot of thermal energy, you might as well take that through the first step of electricity production and then get the waste heat off of the power production. So its economics vary a lot depending on use, and we're looking at actual income from RIN production, renewable identification numbers for generated renewable natural gas in the $25 to $50 per RIN, or million BTUs basically, $25 to $50 per million BTUs. You can actually become an income or a profit center converting your waste into renewable natural gas. Okay, so your least cost conventional fuels for electricity production right now is $42 to $78 per megawatt hour. Okay? Renewables are going to save the day eventually. But let's get there faster if we can. Now, CHP, just to go into that a little bit, everybody knows what a windmill does and everybody knows what a solar panel sitting on a roof does. So let's talk about CHP a little bit. When you look at it, typically your power plants, if they're really good, are about 45% efficient. A lot of them aren't really good. They're down closer to 30, 33%. All right? But let's give them the benefit of the doubt. You're going to run a boiler, and it's going to make heat, and that's on site, and that may be, if you're lucky, Mike was talking about theoretical values about how efficient they were, but normally when we do these, we find them a lot less efficient than that. 60% is really good in most plant operations that we've seen, possibly less. You've got a separate power plant that's running, making electricity, but in the CHP system, you're using the heat to make electricity first, and then you still have the heat to do the job. It has overall efficiency of about 80%. So we're less wasteful in that regard. And this becomes now distributed energy resources. If you can collaborate with your grid electrical provider, you can even let them help run and dispatch your system if there's some sort of collaborative arrangement that you can get to. Arrange an arrangement. Boy, that's bad. Okay, so just to let you know, your traditional conversion losses in a power plant are about 64%. I already said these sorts of things. Let's just skip it. It gets boring. Okay, and we make electricity. Now, the CHP unit, you're going to bring the fuel in. It's going to run through an engine or turbine, and that can be a lot of different things. It can be fuel cells. It can be gas turbines. It can be steam turbines. It can be or organic Rankine cycle turbines or reciprocating engines. So you've got a lot of these things that you're possibly already familiar with that you can touch and use. And then you have to have a heat recovery unit once you've made the electricity, and you often have an existing boiler on site that will effectively do that for you. Okay, you don't have to buy everything new all the time. And then looking at the organic waste streams that we talked about, a lot of food waste, 40% of all food produced in the United States goes to waste. Minimally, 40% goes to waste. That's possibly even before it gets to the market. A lot of stuff, oh my, this cauliflower, it looks kind of yellow. It's not as white as we think it should be. It goes in the waste pile. It doesn't even leave the farm. Okay, so there's a lot of those decisions made. And when you look at what you have in animal production facilities here, you know, you have the pork production facilities that are going out to a lagoon. Well, these lagoons that were in North Missouri were covered now to make it a covered lagoon, and it actually is effectively an anaerobic digester, and it's generating methane. And they put that through gas cleaning equipment, and that is re-injected into the pipeline, the gas pipelines running nearby. And that earns what are called renewable identification numbers, and they can also qualify for low carbon fuel standards in California, Washington, and Oregon, and these are cash flow enhancements to these processes. When we've looked at it, your current market for natural gas out of the Gulf of Mexico at the Henry Hub varies between maybe $5 to $8 a million BTUs, sometimes less. We've seen numbers down in the high threes as well. But the value that you can get for RINs on renewable natural gas is about $28 a million BTUs. And then if it also qualifies for the LCFSs in California, Oregon, and Washington, you can get $7 to $10 million more. It's worth at least $35 a million BTUs in today's market. Don't burn, don't flare, okay? Even if you have thermal processes that are part of what you're doing in the plant, you probably still want to buy pipeline gas to do that so that the RNGs that you create are still injectable into the pipeline. You know, you can take it out of this valve and you can put it in at that valve. Okay? So there's the opportunity. So a lot of people think it's funny, but you're lucky to be in Illinois. Okay? You've got some of the best standards right now for providing renewable energy credits for solar. You are the hot spot in the United States that I'm aware of. There are utility requirements for 25 renewable portfolio. 25% of your power needs to be renewable, and your solar credits are very lucrative, especially in the industrial scale projects up to 2 megawatt of installed capacity. Recent projects we've worked on pencil out to a 2.2-year payback or less. We've seen some that were even more less than 2.2 years. But that's a reasonable one, recently done. So with respect to solar, the tax credits are a part of what's driving this. Right now, you still get in this year 30% credits, and it's dropping in 2020 to 26%, and then in 2022, it drops off to where it's just a normal investment tax credit. So hurry up. RINs were authorized in the EPA Renewable Fuel Standards of 2005, and they've been variously twiddled with over the years, and they're set to expire in 2022 as well. So they may get extended. Those are all political agendas, so we don't want to warrant that that's going to be there. You should also know that capital is not an issue. We have got people chasing us saying, do you have projects we can invest in? We're willing to put up 100% of the capital needed to make energy improvements and renewable energy installations at facilities, and we're willing to do that at 100%. And we'll take the term out to whatever it needs to be so that the plant owner sees a positive cash flow. So if it takes maybe 6 years for it to pay back, they'll take it out 10 years on a payback pro forma so that you see instantly maybe 40% reduction in your annual costs. No money. No additional bandwidth. They'll hire people like us to do the design and the construction management. So you don't have to dislocate personnel. Well, we'll have to talk to people once in a while, so we'll take a few hours a year. But you know, there's outside capital available and wanting to do all of this. Because the market really understands that these things really do pay for themselves. So move CapEx out of the equation and just put it into an operating budget with positive cash flow results. Okay? So, there are benefits beyond the financial. You respond positively to all the buyer chain requests for what you're doing with sustainability. You've diversified your energy supply, or you've improved your resiliency in case there's disruptions, because some of it's actually being done on site. And when you improve energy efficiency, you've generally improved your capital plant, and it generally has longer life cycle. So those are additional benefits. And even if you don't believe in the climate dilemma facing us, you're at least acting like you're contributing to the solution. Okay? And since we're not burning a lot more coal and a lot of other things even locally, you're enhancing your community's environmental quality. Okay, just to point out that it's very cost effective. I don't know really what to do much with this. It's just that the average cost in the US is $10, and 41 cents a megawatt hour. What I want to point out is here in the Midwest, we've got a trifecta of worse conditions. We've got cold winters, we've got hot summers, and we've got some of the lowest costs for power in the United States. That you're swimming upstream with respect to going after efficiency. You've got a lot of both that you need. You need a lot of gas, you need a lot of electricity, but you don't pay a whole lot for energy. So the cost benefits are hardest to make in this area of the country, but we're making it easily. So if you guys have got plants in California or up in New York or New England, those should already be net zero because they've got really good paybacks on investing in this stuff. Okay, triple bottom line. There's ways that we can have our cake and eat it too. Welcome aboard.
Is it better to, let's say you're right now, food facility, we see this all the time, hog farms, food waste going to animal feed or hog farms or whatever. What should they be doing with it, depending on the volumes? Let's say they have high volumes.
If you're talking about animal waste streams?
Animal waste, you know, no, I'm talking about like whatever waste it might have at a facility, like
At a facility?
At a facility. So they're
Okay.
sending their waste right now to hog farms.
Oh, you're sending it to a hog farm?
Sending it to a hog farm.
Well, that's still, you look at what's the value of that you're getting paid for from the hog farm. And you could, depending on where you're at in the area, you could possibly get USDA financing and some grants to go into making your own anaerobic digester.
Right.
We've been working at a couple places that are just flaring the gas off of their digesters. They use it in some boilers, but we're trying to get them to consider upgrading it, making it a cleaner fuel and getting the RNG credits that are available in the market. But if you've already got a digester working, you've got a gold mine.